Hello there, welcome to CXC Math TV. In this video, we're going to be looking at tree diagrams. We're going to be looking at tree diagrams. So you know the big question of the day, what is tree diagram? Now, the tree diagram is just a graphical way in which we're going to be using to tackle problematic questions. So in probability, we're going to see a lot of problematic questions, and the tree diagram is going to be our method of calculating these probabilities. The rules of tree diagram are we add vertically down and we multiply going across. So each levels or branches of the tree diagram always have two possibilities. Now, the best way to understand a tree diagram is to actually do a question and see how tree diagram take place, or see how we utilize this tree diagram. So let's look at an example right here. So this example says a bag contains 3 black marbles and 5 white marbles. Lendl picks 2 random marbles from the bag without replacement. Construct a tree diagram from the problem and then calculate the probability Lendl draws 2 white marbles and calculate the probability Lendl draws at least 1 black marble. So to draw the tree diagram right here, the first thing is we're going to use a little dot to represent the bag. Alright, we're going to use that black dot right there to represent the bag. Now the total marbles in the bag is 3 black marbles plus the 5 white, so that is 8. Alright, so on the first draw, how many black are there? 3. How many white? 5. So that means the chance of getting a black is 3 out of 8, and the chance of getting a white is 5 out of 8. So we're just going to draw now some lines going across. Notice we draw 2 branches. Alright, one represent black and one represent white, and we write down the probability. So that's for the first draw. Alright, so the probability of getting the black is 3 out of 8. The probability of getting the white is 5 out of 8 for the first draw. Now, look at this carefully. If you're to add going vertically downwards, if you add the 3 over 8 and the 5 over 8, notice that that always add up to 1. If we had chosen a black on the first draw, that means we're left back with 7 marbles. So now we know that we can either get a black or a white. So we're going to draw 2 branches off from the black, and then we're going to put another black and white right there. Now, if we got a black on the first draw, right, remember there were 3 marbles, and we draw 1 black, so that would leave us back with 2 black marbles. So that's 2 out of 7. 2 out of 7 would be the chance of getting a second black marble. Hey! Now, the chance of getting a white marble would still be 5 out of 7. Now, why 5? Because if we draw a black first, we wouldn't have touched any of the white. Now, let's look below now. Now, if we draw a white marble first out of the bag, then that would leave us back with 7 marbles, right? But if we drew a white first, then how many whites would be remain? 4 whites would be remain. So that's 4 out of 7 to get a white on the second draw, and 3 out of 7 to get a black on the second draw. This is what we call the tree diagram. This depicts the information of all the possibility of what can happen. So now let's look at the question. The question had said calculate the probability Lendl draws 2 white marbles. So we can let W denote the probability of drawing a white marble, and B denote the probability of drawing a black marble. So we want to find the probability of Lendl getting 2 whites, that is WW. Now if Lendl get a white on the first marble, that is 5 over 8, right? Times, now look at it, in order for Lendl to get white then white, look at the branches. You go white and then look back at the second draw, white again, that's 4 over 7. So multiply 5 over 8 times 4 over 7, and we get 5 out of 14. That will give us the probability that Lendl gets 2 white. So there you have it. Using the tree diagram to do complex probability question is extremely important. Now let's have a look at part 3. Calculate the probability that Lendl draws at least one black. Now, if Lendl draws at least one black, right, then all we need to find out is the probability of 1 minus no black. Think about it. If you find 1 minus no black, now that would take away all the possibility of him not having any black at all. Alright, so the probability of getting at least one black is going to be 1 minus no black would mean he draws 2 white. But we already found the probability of 2 white to be 5 out of 14. So 1 minus 5 over 14 is 9 out of 14. That would be the probability of at least one black. That's one way of doing it. Let's look at another method. Another way of doing it is saying the probability of at least one black is equal to the probability of one black plus the probability of two black, because we can either draw one black marble or we can draw two black marble. Now the probability of drawing one black. Now look at it. We can either go black and then white, or we can go white and then black. Now if we go black and then white, that would be 3 over 8 for black on the first draw, then times 5 over 7. But if you went white first, that would be 5 over 8 times black 3 over 7. Those are the same two things, right? So we can just write 5 over 8 times 3 over 7 times 2. That would be the probability of getting one black. Plus the probability of getting two black now is getting black then black. So that is 3 over 8 times 2 out of 7. And when you put all of that in your calculator, you get 9 out of 14. So the probability of getting at least one black is 9 out of 14. So we can clearly see how the tree diagram is extremely important in doing these calculations. Nice. Alright, now having done that first example, now pause the video and take a look at this example right here. This question says a box contains 4 black marbles and 2 blue marbles. Evan picks 2 random marbles from the bag without replacement. Construct a tree diagram of the problem and calculate the probability Evan draws 2 marbles of the same color. So go ahead, pause the video and attempt. Now, in attempting this question, we can first start with a little dot to just represent the box, right? And what are we going to get on the first draw? You have 4 black marble and 2 blue marble. So we draw our 2 branches from the box and label it black and blue. Now, 4 plus 2 is 6, so the total marbles is 6. And so that's 4 out of 6 is the probability of getting a black on the first draw, and 2 out of 6 is the probability of getting a blue on the first draw. Now what if we draw black first? If we draw black first, then we're left back with 5 marbles, and so on the second draw, we can either draw a black or a blue. Now if we drew a black one first, and we're now left back with 5 marbles, so the probability of getting a black on the second marble is 3 out of 5. And the probability of getting a blue marble is 2 out of 5. Now what if we draw the blue one first? Now if we drew the blue marble on the first draw, then on the second draw we still have 5 marbles, but now we only have 1 blue marble left back. So the probability of getting a blue on the second draw is 1 out of 5. And the probability of getting a black on the second draw is 4 out of 5. So now we need to calculate the probability Evan draws 2 marbles of the same color. So let L denote the color of blue and B denote the color black. And so the probability of the same color is we need to find the probability that he gets 2 blue plus the probability of 2 black. Remember. The same color just means he can get 2 black or 2 blue. Now the probability of getting 2 blue is going to be getting the first blue is 2 out of 6 times the second blue 1 out of 5. So it's 2 out of 6 plus 1 out of 5 plus the probability of getting 2 black. Now if you had gotten 2 black, that is 4 out of 6 times 3 out of 5. That works out to be 7 out of 15. And so the probability of getting the same color, meaning 2 blue or 2 black, that works out to be 7 out of 15. That's nice and easy. Nice. Alright? Lovely, lovely, lovely. So that takes care of this question. That takes care of this tree diagram question. And so stay tuned for more as we continue with more Csec additional mathematics topics